Hello everyone. In this video, I will be discussing on physical and logical address in the X086 process. How the physical address is being generated, how to form a physical address, and what is an logical address, what is the usefulness of logical address, and how to generate the physical address, and what is the usefulness of physical address. We will be discussing in this video. And before we go ahead with this one, first of all, a small thing about what is a memory segment and how we will be having a memory segments. And you can see in this picture at the left side, you are shown with an total 1 MB of memory. This is the starting address I have taken from 0000, and the last address I have taken, the initial address is 0 F000. It will be extended with 5FFF. So this would be the last address 002. So when we are considering a one memory segments, so totally when you are having each is of 64 KB segments, so totally you may have overall here as 16 segments. So what of this one? Randomly I'm picking up one segment, and this is my segment. So the starting address of this segment is given by 8000, which is given by one of the segment register. So you will be having 4 segment registers as we have seen in the previous video of register organization. 4 segment register, data segment register, extra segment register, and stack segment register. One of these registers, one of the register will use to represent the starting address of the memory segment. And at this starting address of the segment, we will be having the base address, I mean to say offset address as 000. It would be actually. Suppose the address is represented as 8000 is to 0250. This way of representation of the address is called logical addressing. There is certain logic in this one. First representing the segment address, followed by colon, followed by what? Offset address. So this is the extended from 0 to 5. This is the location. So if it is you have given is the address as 0800 is to 5000. So that would be somewhere over here. This would be a command. And what is the scope of this address? So the scope of this offset address would be from 000 till what? F F F F. So this would be a total 64 KB segment scope of it. So anything represented over here, this is called as logical addressing. So here for each of this segment, let's say I am going for the 6000 segment. If I represent this address 6000 is to 0700. So what happens here is that from 600, when I take this point, from here it would be started from there. From there it would be extended to 700. Somewhere over there it would be 700. Starting is what? 6000. 6000 starting offset address, it will start with what? 000. So you will be started with 000, and then it will proceed into the next one. So next one, coming to the how the memory address, I mean to say, memory address is being generated in a mail. So microprocessor 8086, the major memory would be generated by the bus interface unit. Bus interface unit generates the physical address in two ways. How it generates? Bus interface unit, what it does is that it takes a segment register. Let's take any segment register is being multiplied with 10H. Is nothing but hexadecimal 16. That is the 16 value. It will multiply. And when you go for this value, it will multiply with this one and add the offset address. Add offset address to this one. So this plus offset address you will be getting the physical address. So this concept is being taken into consideration for generation of the memory address. So let's take this an offset address. So offset address and segment address. So the segment address, whichever it is a 16 bit, multiplying with 10H is equivalent as appending 4 zeros onto the right side. This will be the same thing when you go for this one. Because as we know that this is 2 power 16, this is 2 power 4. So when you are multiplying 2 power 16 into 2 power 4, obviously you will be getting 4 zeros extended to this. This is the general concept you will be having. Now this one is being added up using of an adder. So once you get this one, you will be getting a physical address of 20 bit. This offset address into segment address appended two zeros or multiplied with 10H. This is equal to what? Multiplication with 10H. Then adding about this one, you will be getting a physical address. This is the way the physical address is being generated. Let's take if you go for some calculation. Suppose the data segment starts with location as 100 H. So 1000 H is the starting address of data set. Now the data reference contains an address of 29H where the actual data is there. 29H is the location where the data is there. So how you get the where the actual data is there? 100 is the address, okay, the offset address. 29 is the offset address. Segment address is like this way. So you can see over here. Segment address is what? 100. I will do this one 10 Hz, which is equal to what? 10000 plus 29 is been added, and you will be getting as 10029H, which is the physical address or where the actual data is present. Then when you see all these physical addresses, you know where it will get it from. Same thing is then, this is the offset address, this is the physical segment address, this is multiplied with 10H or appended with 4 zeros, and then these two are being added, you will be getting this number. So the same thing over here, physical logical address is represented as segment address by offset address, you will be getting the logical address. And when you go for physical addresses, it's been shifted by segment address with 4 bits onto the left and adding the offset address, and we are going for appending zeros onto the address. That is how you go for physical address. Physical address, when we go for this example, A A4 FB and 0 plus offset address is what? 487. When you add these two, you will be getting as A will go for 2, B, C you will get F and 8, you will get as 8 over here, and then 7. So you will be getting over here 2 and a carry over here 8, and then you will be getting 9. So this is the result of these two are added, you will be getting this result. This is an physical address. So we will get physical address. The same thing has been shown over here. Segment address multiplied with the appended 40 as the offset address, you will get the physical address. So you can do this exercise. You can perform how it where the resulting of physical address. These two examples. Code segment is 0A8206 and instruction pointer is 0E24H. Where is the resulting address? These two we can perform it. So one more example is being given, and you are remember here. Very important thing over here is that physical address. Can even overlap the memory. It is not compulsory. 64 KB segment after those even that we need to take a look. So we need this address would be there. That is going to be, and so this will be the address of values already I think we have, and this one what segment address is corresponding to the linear address 28F30H? Will you take this one? Here I can take it as a 3 0 0 0 0 is my segment address. My offset address is what? Offset address is what? 0 and 3 0. This will be the offset address. I can define 2000 as my segment address, not the segment address. 800 is the segment address previously. Now 2000, I can define it as 28FT is my segment address. The remaining is the different. And I can define n number of ways. 5000 is my segment address. Or 2000, whatever it is. So the remaining part. So here, what do we have? 28F30H. What the segment address is there? You can have 500H. The remaining is your offset address. So whatever I take it an offset address out of this one, the remaining part, or when you say from 8 this part, once you take it an offset address, remaining part will be a segment address. This is about the shown with it. Obviously, when you see all these examples, you can easily generate how to get an physical address. See here, segment address multiplied with 10h and plus x address, there is a segment address. The representation is of the address segment is the effective address using logical address. Now here, logical addressing mean to say if I given a 8900, then this is called as physical address. 20-bit address is physical address. The same, if I give it as 2900 is my segment address, and the remaining is what? How much? 500. How much is that? 6000 is my 3500 is my offset address. So if I represent the same thing, I can represent this one as 2500 is to 3500. So when you are representing this way, this is called as logical addressing. This is called as physical addressing. Now here, it will know the exact location of the memory, physical address, that is the advantage. And here, the representation of the address can be easily understood by the user. Go to the segment address as 2500 and 3500 is the offset address within that segment. It can do it directly with it. So this is the way how physical address and logical address are represented and how these are used. Thank you for watching this video. If you have understood this one, if you are having any doubts, you can. Thank you.